want to take this moment to do a quick recording on the introduction of logic. Now, logic occurs in everything. Okay, it occurs in life. Logic requires making a decision or a basic sequence of operations to function, which is what everything in life does. Life is made up of choices and options, as is any piece of equipment you're ever going to work on. This is the language of logic. Logic is the basis for all computer programming, communications, and in the case of heating, ventilation, air conditioning, and refrigeration, everything the equipment does. So we have to start off with the basic assumption that everything has an input and an output. There's a condition being measured or watched or observed, and based on that, there is a decision that's made that causes something to happen. Every logical path has inputs and outputs. The programming dictates what happens in the path based on those inputs and outputs. We're going to talk about conditions. A condition is the basis for making a decision. Is the number 4 larger than the number 2? Is the number 4 equal to the number contained in the letter A? Is the number 4 greater or equal to the number 7? All of these are conditional statements. The basic conditions are the greater than sign, which is the first line on the left, the less than sign, the equal to sign, the not equal to sign, the greater than or equal sign, or the less than or equal sign. Ignore these little dots that are just from the PowerPoint statements, but we're looking greater than, which sometimes is just written as GT. Less than could be written as LT. Equal could be written as EQ. Not equal could be written just as not. Greater than or equal, GE. Less than or equal, LE. Those are our basic conditions. We can evaluate every single input for something conditionally based on these conditions. The results of the condition is once every condition is evaluated, there's a result. It's either true or false. Or in machine language, this would be a 1 or 0. Okay, so if we go back to our conditions here, we have a greater than. Okay, so let's go back here. Is the number 4 larger than the number 2? Yes, so it's true. Is the number 4 equal to the number contained in the letter A? Of course, you'd have to know what's in the letter A to evaluate this condition. Is the number 4 greater than or equal to the number 7? This would be false. So everything ends up with a true or false based on the condition. Logic comes next. It's what you do with this result. So we have actually 5 logical expressions. We have AND, OR, NOR, NAND, XOR. Those is the basis of everything we do with logic. Okay, AND is simple. And if we look at the chart here, and what we have here, this is an AND gate. It's just basically 2 inputs and 1 output. If input number 1 is true because we have true and false, the output is non-existent. It's basically 0. If input number 1 here is true, output still is 0. But if input number 1 and 2 are true, we get an output. So AND basically says both conditions have to be true in order to cause an output that is true. Think about it with a series circuit. A compressor will be energized if the low pressure switch and the high pressure switch are closed. Or a light bulb will glow if switch 1 and switch 2 are closed. There's a key word in here. It's AND. Okay, it takes both of these conditions for the result to happen. OR is slightly different. If we look at the OR chart, we still have our input and outputs. We have 2 inputs and 1 output. The first line, input 1 and input 2, has nothing, so we don't get an output. The next line, input 1 is 0, but we have an input 2 and we have an output now. The third line, we have an input on input 1, don't have an input on input 2, and we have an output. Then we have two inputs and an output. Okay, so if any of the conditions are met, we get an output. Now let's put this in English. Think about a parallel circuit. The fan motor will be energized if either the fan on switch or the combo fan limit switch closes. Typical heating furnace, forced air heating. Think about it in something simpler. The hallway light will turn on if either the switch at the top of the stairs or the bottom of the stairs is turned on. These are in parallel. So when we're dealing with or, it's always in parallel with. You have more than one option. So your switching devices are next to each other. Then we get a little bit more complicated. We have the XOR. Now the XOR is a little bit weird, okay, because it's an OR, but it doesn't allow both inputs to be on at the same time to get an output. Okay, it is truly an OR. Okay, in our prior one, remember, if I had both input 1 and input 2, I would still get an output. In the XOR, it builds on that, but it's very strictly, you have two choices. It's either. So let's think about it from a heating cooling perspective. The air conditioning or heating will work if the thermostat calls for either heat or cool, but both cannot run at the same time. Again, the air conditioning or heating will work if the thermostat calls for either heat or cool, but both cannot run at the same time. Then we can also look at the NAND. Okay, same principle. Okay, however, it's basically saying that, okay, it's the opposite of the AND. So remember, our AND required both inputs 1 and 2 to get an output of 1. In this case, okay, it's the reverse. If we have both inputs 1 and 2, our output is 0. So it's a reverse of an AND. And you can think about this one, okay, working the same way as the AND, but with a not in front of it. If switch 1 and switch 2 are closed, the light bulb will not operate. How about a normally closed relay contact? Okay, if we do anything to energize that coil on that relay, the relay coil will switch the normally closed to an open and the normally open to a closed. Anything connected on that light bulb would be a negative condition. The NOR does the same thing, okay? The NOR says, I'm going to work as an OR gateway, but it's going to be a negative, okay? It's a reverse. So if you look at line 1, neither 1 or 2 are a positive number, okay? Neither 1 or 2 are true. So our output is a 1. For every other condition in this chart, we have an input. So our output is a 0 or false. The NOR operates exactly the opposite of the OR. If either switch 1 or 2 are closed, the light bulb will not operate. That's just putting it into English. By evaluating the logic contained in any schematic or action, you can describe the sequence of operation. Remember, AND is in series with, OR is in parallel, NOR is a normally closed condition in parallel with. NAND is a normally closed condition in series with. XOR is the same as OR, but one or the other options, not both.